Good afternoon. I'm Addison Snell with Intersect360 Research. We are industry analysts in the high-performance computing industry. I recognize a lot of you. I'm delighted to be part of this conference, which I'm just thrilled at the growth of this conference, by the way, not only locally but internationally, all around the world. This has really become, I think, the leading conference for discussion in the HPC community. Obviously, we have the big trade shows like SC and ISC, some of the industry-specific ones for particular vertical markets, but in terms of having an actual conversation about the work that's going on in the industry between the users and the vendors, this has really been an outstanding conversation ongoing, and we're thrilled to be part of it and be a media sponsor. For those of you not familiar with Intersect360 Research, or if you're not keeping up with us in our newsletter that you can sign up for on our website, we do have a couple of things that are new. So we're industry analysts. That means we do the things that analysts do: market sizing, trending, segmentation, forecast, write white papers, things like that. We do have a user organization called HPC 500. If you're an HPC buyer, not one of the vendors, we like you guys to pay us, but the HPC end users can sign up for HPC 500. That means you participate in our surveys from time to time, and we'll give you all kinds of great things: access to our research. We have quarterly conference calls on topics of interest, things like that. We also have a new podcast series that we've just introduced. Myself and my co-analyst Michael Feldman host This Week in HPC. That's on our own website and also on insideHPC through Rich Bruckner. You can follow at This Week in HPC on Twitter. We're working with the Council on Competitiveness on a special study looking at the potential applications in industry, particularly US industry, for exascale computing. You can get all kinds of updates from us. Follow Intersect360 on Twitter or get on our newsletter, things like that. My presentation today, I'm going to give a little bit of a market update, although it's a funny time of year for it, and then I'll do some of the reactions from supercomputing and recent news in terms of setting up what we're looking forward to going forward into 2014. The reason I say it's a funny time of year to do it is because although 2013 has ended, it's only the first week of February, and it typically takes a quarter before we can wrap up the previous year. We're looking for final quarter-end numbers from all the major vendors, and we typically get a new market model out in the April to June quarter that ends the previous year and looks ahead. Nevertheless, regardless, HPC has been a growth market, predominantly driven by growth in commercial, and I'll get to a forecast in a second. You can see that we're tracking all of the different areas within HPC: servers, storage, services, networks, other. The server component of the market is only about a third of the overall spending going into the market, $10 billion in 2012. That'll be up around $11 billion in 2013. Do I have a laser pointer on this, Brian?
It's right on the very top.
The very top one. Awesome. You see this huge growth in I don't know how to do the laser. Never mind. The huge growth in the storage number, 26% growth. That's not real 26% growth. There's a figment there. What happened was, for those of you who can remember this far back, there were some pretty serious floods in Thailand in the second half of 2011 that had the market effect of deferring a lot of shipments and a lot of revenue from the end of 2011 into being recognized in the first part of 2012. So 2011, from a storage perspective, wound up being a year that only had 9 or 10 months in it. And 2012 had 14 or 15 months in it. So then that'll come back down a bit in 2013 as you go back to a year that has 12 months in it, and then it'll finally even out. This is one of the problems with tracking revenue, is sometimes weird stuff like this happens. And when you go into a forecast, it can get even stranger. Where this gets interesting is when we look at the vertical markets. there are a few things to say here. We are taking a fairly inclusive view, and have done for the last 5 years, in terms of what applications are part of high-performance computing. We'll hear people tell us, well, we're in HPC and other markets like media and entertainment and finance. Okay, we think of finance and media and entertainment as HPC vertical markets, that HPC is broader than just the science and research labs. We have 2 super segments at the high end. High-performance technical computing for science and engineering types of applications, and high-performance business computing for the non-scientific business applications. I'm sorry that the type on this is so small. It's a figment of bringing the charts in from Excel, but you'll be able to get these slides online, I'm told. Even in the technical computing side, that's 40% commercial, because you get industries that are doing science and engineering for profit, like automotive manufacturing and pharmaceuticals and drilling for oil. These are for-profit companies that are doing science and engineering. Then on the business side is almost all commercial by definition. The biggest segment there, the blue one in the top right, is financial services, which has actually grown to where it's the largest commercial HPC segment, slightly larger than the 2 manufacturing segments combined, the large product manufacturing, consumer product manufacturing, which are the red and green segments on the left at about 2 and 3 o'clock in that pie chart. I should have said that although the pies are drawn here for simplicity, be the same size, the pie on the left is twice the size of the pie on the right. 2/3 of the market is high-performance technical computing, and 1/3 is high-performance business computing. If it helps your peace of mind, think of the one on the left as a deep dish pie and being twice as thick. There's that much more over there. Obviously, there's government and academic spending in this market as well. I will also say, while I'm on this slide, that this is significantly different than another analyst firm's methodology for the HPC market. You know, they can answer to their own methodology. This is the way that we're tracking the market. Okay, now going forward to forecasting, I love this thing that my great partner Chris Willard has said once, that when you create a forecast, it has to be bound by what's realistic, but reality has no such constraints. So you forecast the market and you try to predict at a high level the way things are going, but then unusual things like floods happen and they're just outside of your forecast methodology. You didn't try to account for them. That said, the forecast is for continued growth in high performance computing. Now, the step from 2012 to 2013, which is about 6% growth in this picture, I think we're going to come a little short of that. In our model for 2013, when we were forecasting it a year ago, we didn't forecast a government sequester that was quite so thorough. Now, we weren't exactly forecasting government as the high growth area. We had it at flat to small growth, and we haven't yet gotten into the room yet for the big day-long throwdown for forecasting, where we all have to beat each other up until we agree on a forecast. But my prediction is that we're going to see a miss on the public sector side, even from where it was, and the government spending might have even been down a little bit. I think HPC as a whole will still be up, but we're seeing still a lot of continued weakness in public sector spending, not just in the US. Europe is still really slow with the lingering effects of the Eurozone crisis. But nevertheless, long term, I think we do see growth in HPC, and we'll continue to do so. We'll get a revised forecast out in about 2 or 3 months. All right, now where it gets interesting is when we start talking to the end users. That's all on the forecasting side. We drive the majority of our research through an awful lot of end user surveys. We have 2 major anchor surveys that we do every year. If you join up for HPC 500, which I hope you will, these are the 2 that we really care the most about you participating in if you can, and will protect your anonymity. One we call our site census survey, which asks, will you please tell us, if you can, everything that you have installed and how long you've had it. And that's servers and processors and interconnects and storage and middleware and applications. So it's a pretty dense thing to fill out. It'll take you an hour to really go through and tell us all this stuff, even if we make it as easy as we can. But this is really valuable information going forward. The other is called our budget map, which is looking at if you consider your HPC budget as a whole, what percent goes to hardware, to software, staffing, facilities, services, and then to items within each category, which gives us a pretty good map as to how much gets spent on this versus that and helps inform our total market models. In our most recent site census reports and other qualitative research we've done beyond that, we're really at a major point here where it's difficult for end users right now because we're into a new era of parallelism, and this is one of these situations where, like it or not, revolution is upon you. There's not even the option really to stay the course and just do more of the same, because even staying on the x86 train implies going to a new level of parallelism on the socket as you add more and more cores. Now you could choose to look at something like accelerators or other types of esoteric architectures. I shouldn't even say esoteric, I should say proprietary or specialized architectures. But in any of these cases, you're really confronted with what does parallelism look like, even not necessarily at the exascale level, at the petascale level, at hundreds of teraflops. What am I doing for parallelism at these new levels of scale with the new technology? How do I plan that balance between the processors, the cores, the memory, the interconnect? Do we need to look at new types of parallelism? I loved Professor Panda's presentation earlier. I think that discussion of MPI and its evolution is absolutely right at the crux of where this market is going for the next 15, 20 years. And then beyond that, there are implications as to what it means for the skill sets of the people in the HPC industry. If you look at more recent transitions, like what happened when we went from SMPs to clusters, large scale in the community, what it meant to be a programmer or a system administrator, the skill sets changed there. Even something like a sysadmin, you went from a time when most of your experience had to be on the operating system to shifting to where most of the experience had to be in middleware of some kind. You really, for the same title, had to have a change in skill sets, and I think we're going to see a lot of that going forward over the next decade, that you're going to need to see new skill sets get refreshed in the HPC industry. Here's a big reason why. This is a chart that we've been tracking for several years out of the site census. The bottom line in green is average memory configured per core in a system, how much memory per core. And that has stayed relatively constant. In fact, it's grown a little bit. It's grown a fair bit over the last 5 years by about 30, 40%. Configured memory per core has gone up. Well, if configured memory per core stays flat or even goes up, and you look at the architectural choices we're making with more cores per processor and more processors per node, which has also gone up on average, although it's still around 2, the average is skewing up a little bit. The average amount of memory per node is now, for systems installed since the beginning of 2012, and we're another year past that now, over 80 gigabytes per node, and still increasing roughly exponentially without showing a great deal of sign of slowing down. That has a great deal of implications in the programming model, in how do you efficiently manage these systems at scale, which goes directly to the conversations that Mark and DK had started earlier today. We are seeing accelerators get adopted. This went up in 2012. Shoot, I meant to update this slide. We have an updated slide that shows that that blue portion went up to about 44% of systems in our survey are showing accelerators. Now, that's not the same as what percent of end users are at least experimenting with accelerators, which is much higher. And nor is it the same as what percent of your workflow is effectively leveraging accelerators, which is much lower. What we are seeing is continued adoption and trial of accelerators. We're still fairly low on the wide-scale adoption of accelerators. A lot of this is wait and see, and if there's another architecture that's out on the horizon that people are starting to to show some interest in, we're going to experiment with and play around with, see where it goes. It's ARM. Not to be overly processor-centric about this whole thing. I can't tell you how many times I give a presentation like this and then I go to talk to one of the storage vendors and they say, you analysts, you're all about the CPUs. Honest to God, I care about the data side. I've spent so much of my personal professional development learning about things like parallel file systems, tracking that part of the market. The thing is, the processors are part of this too, and this is a very real transition point in the market right now that users are really struggling with. And when we do even the qualitative discussions just with really sophisticated end users and we say, what are you optimizing on for 5 years from now? The answer is, don't know. We're going to try it all and we're going to wait and try to see what wins. There's a lot of uncertainty in the market around this right now. So some of the challenges of architectural trends. I'm sorry, I have to stop and ask you, Brian, how long am I on for? Well, I thought I was on for an hour on the agenda, and this clock here is ticking down and telling me I have 5 minutes left.
I don't know what that clock is.
It's telling me I have 5 minutes left. So am I hurrying or am I still going? How long do you want me to go? How long does everyone want me to go?
What clock are you talking about? No, you're
There's a clock right here ticking down, flashing at me. I'm at 4:35 and counting down like there's going to be a trap door and boom, I'm out of here. All right. All right, okay, I'm good. Okay, so some of the challenges about that. It's distracting though, right? So we talked about the parallelism and the no, it's cool, I can ignore it, it's fine. I'm a professional, I'll rise above it.
Let's give it 15 minutes first check.
There are some challenges that go along with this. Power consumption is one of them. You know, we're talking about power consumption at the high end for exascale, but it's not just at the exascale level where this is hard, because even at what we've been trained to think of as a relatively fixed level of capacity, those increases in cores, increases in memory are making it more expensive to do relatively the same amount of computation for the same effective application performance at each level of scale. Plus, cost of memory is, you know, this is getting to be one of the really most expensive portions of the system. We'll get our clients ask us, well, what's the typical price of a system for this many nodes? And the number one question back is, how much memory are you going to put into it, right? Because that's a really expensive component, and if you have more or less memory, it really swings the price of a system. Models of parallelization has already been well discussed today. It's a bullet on my slide, but DK gave an excellent talk on that together with languages, programming models, especially if you're going to be on an accelerated type of solution, or you're going to go to CUDA or OpenCL or something else like that. System efficiency. This is getting into, you know, this discussion of exascale. I already talked about the personnel thing here, so I'll pause on system efficiency. You know, what we're really talking about is trying to get the application to scale when we go on to all these things. And we've brought up all these conversations about exascale, and I kind of kicked off the conversation a little bit when I was needling Mark about his presentation. And it's not his fault, it's just that the word exascale is starting to bug me. And it's because, you know, we're analysts and I don't know what it means. Except that it might mean exaflop. I think when people say exascale, they mean exaflop, right? Other than maybe we feel like we're acknowledging that there's a lot of work to be done by calling it exascale and we're pointing out all of these different things. Does it mean exaflop or not? Because the exa is a specific mathematical prefix, right? It means, you know, 10 to the, however many is it now, 10 to the 15th? Means 10 to the 15th something. But scale doesn't attach to that. It's like, you know, what was the cartoon Megamind with Will Ferrell, right? Does that mean he's got a million brains, or is it just colloquial, right? Is the next villain going to come out and be Petamind and be, you know, yes?
Q&A actually is 10 to 18.
10 to 18, sorry. So it's 10 to the 18th what? And with exascale, you know, if it doesn't mean I'm happy for it to mean something other than exaflop. But I guess if it means something other than exaflop, we should be able to say what it is without waving our hands at it. If you're going to point to any exaflop system and say that it's exascale, or say this is an exascale system, but it implies that it's exaflop, then they're the same. It's a bijection, right? If they're not the same, then you have to be able to tell me one that's not the other. Yes, that's an exaflop, but it's not an exascale system because blank. Or this doesn't have an exaflop, but it is exascale because why? I don't know. But until we can do that, they're really the same thing. Now, I would actually kind of like it if maybe there were multiple hurdles something had to clear in order for you to call it exascale. But then maybe we need to define what those are. And I don't know if we wrote a paper on that and said, all right, exascale is going to mean this, if anyone would care, or do we just want it to mean exaflop? But the reason it's kind of bugging me is because we're using them to mean the same thing. And if we want to really put a stake in, no, what we mean is that these systems have to perform efficiently at scale for particular applications, then let's see if we can define that. Okay, supercomputing is a big conference of the year. Everyone always asks us what we think about it. It was pretty recently. Starting from the compute side, there were not major system announcements from the top vendors this time around. There weren't like a whole lot of refreshes. Here's a brand new system. There was one new top 10 system, the Cray one in Switzerland. Where there were a few new system announcements were in the next tier out. This Russian company, RSC, had their new system that they launched under the headline Petaflop in Iraq. That one did turn my head a little bit, I gotta say. You know, I can remember back to when a petaflop was a lot of compute. You know, it was a pretty substantial system. Now RSC is cheating a little bit. The rack is a little bit wide. It's a little bit deep. It's a little bit tall. But it's still a petaflop in a rack, which is a pretty good headline. You know, and they were the first to be able to achieve that. D-Wave is starting to really attract some HPC talent, and I'm answering questions about quantum more and more, which I love trying to do because I get to try to sound like I understand quantum mechanics, which I do not. There's one other secret company that we've been tracking that's been kind of interesting, where they're taking a novel architectural approach to try to solve the types of so-called hard problems that are not well aligned to LinPack, and go over to things like GUPs and FFTs and sparse matrix linear algebra. I think there's room in the market for an architecture to do stuff like that, and I'd be interested to keep tracking technologies that do that. Now on the processor side, there was bigger news, particularly with the Kepler K40, which was all over the green 500 if you like that kind of benchmark. Intel, not to be outdone, gave a lot of details on the future of Xeon Phi, in particular of the Phi component being a separate, a standalone processor, which for those of us who remember all the way back to Larrabee is kind of fun, with the insistence that it was this graphics chip that was only a coprocessor. Now we're really seeing in the roadmap this come full circle around to here's this many-core chip in Intel's roadmap. The automata chip from Micron was kind of interesting. We did some talk around that. And then outside these other announcements, we're hearing more and more about liquid cooling. Mostly from the vendor side so far. We haven't heard a lot of end users coming to us and saying, what really we see on the horizon is the big deal is we're going to go liquid cooling to hit these levels of scale. But the vendor community is putting out a lot more self-contained liquid cooling apparatuses, and there might be a trend there going forward in terms of how we're going to achieve more scale. On the data side, there were significant new announcements on the storage side. A couple of major product platforms. NetApp, I'll start there because they are actually the top HPC storage vendor by revenue. Not like by a huge margin. This is an extremely disaggregated part of the space that's fairly confusing because everybody resells everybody else's stuff, but in our market model, NetApp is the narrow market leader by revenue. But they introduced this E2700. This is the E series line. That's the one that was the Ingenio product from LSI that they bought and integrated into their line as the as the E series. That brings their higher performance E5400 to the smaller form factor. They also had some, what do they call it, the EF flash arrays, the EF550 also came into the market from NetApp. Xyratex had the ClusterStor 9000 now. That's a new product announcement. And then there's been more new news with Xyratex since that's now at Seagate. So far, Seagate has flagged that everything is business as usual at Xyratex. They're managing that as a distinct line of business. There are a number of things that could happen with Xyratex going forward, and I will completely refrain from commenting on all of those possibilities. But the ClusterStor 9000 was a double-up performance gain from the previous generation, and I thought the more interesting features there were down at the software level, things like the grid RAID and the CIFS and NFS gateway features, potentially giving you more enterprise adoptability of some of these higher performance features. DDN, not to be outdone, most interesting thing there was their forward-looking strategy, this infinite memory engine, IME, which looked at first, when they first described it, like it's a flash layer, like for I'm going to accelerate my metadata with flash. But it's more integrated than that as a strategy. It's more of a non-volatile memory burst buffer where the storage is architected around the idea that you have these NVM accelerators throughout the architecture. They gave a few more details of that at their most recent analyst meeting this week. Big data, of course, is a major theme, and that is completely appropriate. There is a huge overlap between big data and HPC. Now, they are not the same thing, and I would not endeavor to subsume one of them into the other one of them. I think it is hazardous to declare that big data is HPC, and I think it is equally hazardous to declare that HPC is big data. I think that you can cite examples of big data that is not HPC and HPC that is not big data. There's plenty of room for that. But if you take this concept that big data, okay, first of all, I agree with Mark earlier that big data is not a synonym for Hadoop, right? Hadoop is one framework for addressing one type of big data problem. But if you approach big data as it is the growth in the creation and accessibility of more data and more types of data, stressing an organization's ability to manage it or gain competitive advantage from it. If you take a definition like that, then there's a lot that goes beyond Hadoop, but it does arc toward high performance technologies, and we've done a lot of research in and around that. But, you know, gosh, there was so much big data at supercomputing, I almost missed the stuff that wasn't big data. Like, can you come tell me about quantum chromodynamics or something like that, right? I agree, it's a huge opportunity, but it's not everything either. Also on the data side, from the storage side, we're hearing more and more about object storage. So this is the parallel to my liquid cooling on the previous slide. Again, this is coming mostly from the vendor community. We've not seen a lot of object storage show up yet in our site census surveys or our big data surveys, particularly in commercial installations. Not a lot of conversion to object yet, but it seems to be on everybody's roadmap and might be a technology to watch in terms of next generation of how the market's starting to evolve. Okay, a few looking ahead topics, and then I'll be able to take questions, and people can hit me back from the questions that I was asking earlier. Looking ahead, HPC in the cloud. And I put the cloud in quotes here. This is another definitional one that starts to bug me. And I'm not going to be the analyst who gets to drive what the world calls cloud computing, okay? I will merely submit that when we hear cloud, I think there are different warring categories of definitions that people use that mean different things, and you should be clear about at least which category you're in, right? Within HPC, the most useful construct we have is the notion of cloud computing as a utility computing kind of delivery mechanism. I'm going to run my application on someone else's infrastructure. I've outsourced part of my IT infrastructure or workflow to somebody else, and I pay for it through some sort of utility pricing basis, even if it's licensed by month or by year. That is a definition of cloud, and it's the one that I think has the most pertinence to HPC. Generally, you know what that resource is. Even if it's Amazon, you have a pretty good idea of where it's going, what you're running on, how long it's going to take, what you're paying for it, et cetera. Another definition of cloud that we hear, not so much in HPC, but people will talk about cloud as an architecture. Someone will point to their compute room and they'll say, this is my server infrastructure, it is a cloud, right? This is the notion of cloud as a type of virtualization that's balancing jobs across what we might refer to as a cluster or a server farm, but the virtualization implies that it's a cloud for some reason. Google uses this definition. Google coined the term cloud around this notion. And I'm fine with that too, but it's generally not what we're talking about. And then the third one that comes up a lot is the idea of cloud is this, it's a consumer-based definition, the idea of the cloud as this singular, ubiquitous, ethereal place where magical things happen. And people will talk about the cloud the same way you talk about the web or the internet or maybe heaven, right? It's not this, right? Where's grandma? Well, she's in the cloud, right? Like that. And this is a consumer definition that like Microsoft or Apple use. I'm storing my music in the cloud. My phone is backed up in the cloud. And I really don't have a good sense of where that is or how it's paid for on my contract or what the resource is or how it's done. I don't care. I'm really ambivalent to it. And that's a very consumer-oriented. I'm okay with that definition too. But generally, now when I'm hearing HPC in the cloud, to me, that's different from my music is in the cloud. I don't really think we're going to get to the point where my HPC application is in the cloud, the same way my pictures are in the cloud. I don't think it's appropriate, and I don't think HPC is going there. So that was my long digression about HPC in the cloud. We do have our first HPC-specific cloud forecast because so many people are asking us about it. It is part of the market. It is about 3% of spending. That is pretty good growth from where it was about 40 years ago at a little less than 2% of spending, right? Utility computing has been around HPC for decades. It will continue to be around HPC for decades. Most of what you're seeing as HPC cloud now are constructs that existed before. If British Petroleum is outsourcing its data capture to Schlumberger, who's running BP's custom algorithm and then reporting the results to BP, is that a cloud? You know, that fits most people's definition of cloud today, but they've been doing it since way before we were talking about cloud, but it's kind of in there as this utility computing definition. It is growing at the same rate the market is growing. It is not really taking over the market. It is about $600 million in 2012, and half of that is raw cycles. About half of the rest is different types of application embedded things like SaaS, where I'm going to run a specific application in a cloud environment. The guidance we tend to give our clients around this is it is a real market, but it's overcompeted for the size of the opportunity. It is not a panacea that the whole market is stampeding toward. And moreover, if I think through all of the HPC sites I know, and I can name a fair amount, and I think of every machine that costs more than about $250,000 and think, could that system get replaced by cloud where I'm not going to use that system anymore? I'm going to say, forget it, I'm going to retire that and move everything to cloud. I generally come to the answer, no. There are two fundamental use cases where we do see cloud. One is at the very entry level where you have a true new adopter of HPC who hasn't done it before, and they start using cloud resources rather than investing in their own in-house technology. We do see that. That's one. The other is for occasional cloud bursting over peak, right? But when I say occasional cloud bursting over peak, generally what does make economic sense in cloud is I need a lot of extra capacity for very little time. If I don't need very much extra capacity, I can just wait until it's available in my own internal system. And if I need it for a long period of time, then it's worthwhile for me to buy it. right? Now, both of these are by definition relatively low volume transactions. So although it's pretty easy to go around and find people who use cloud occasionally, right? We find that 25% of the end users we survey use cloud, HPC cloud at least occasionally. So that sounds like a lot. But typically, it's for less than 5% of their workflow. So you go less than 5% times 25%, and you're back down to what percent of the market that it is. So there's that with respect to cloud. The most recent survey, before I leave this chart, the most recent survey did tick upwards from a little below 3% of spending to a little above 3% of spending. We haven't, again, had our whole bare-knuckle fight over whether that's a trend or an anomaly in the data. You get 1 year of data that goes from 2.8 to 3.4, and it's tough to say, all right, we got to redo our forecast for more cloud. So, you know, stay tuned. Maybe it'll come up a little, but most of the analysis I just said all stands. Oh, I just did this whole slide, so never mind. Oh, other than private cloud is an entirely different animal. Okay, we see lots of private cloud. I like to say that comparing public cloud to private cloud is a little bit like comparing American football and European football. There are some high-level similarities between the two. You know, there's a big green rectangle with people running around. There's a ball. There's a referee who has a whistle and a flag. Okay, but then there are differences in implementation. Okay, they're really very different things. And everything that I said was all public cloud. Private cloud, entirely differently. If you are trying to market cloud solutions, I would back off of telling people why cloud is great. I think people have heard plenty about cloud for now, and you don't need to go try to sell someone on the idea of, you know what, cloud's really awesome. I think you're better off saying, do you have an internal cloud initiative? If they say yes, you say, well, look, this can fit in with all of everything you're doing in the private cloud, and it bursts to public cloud as desired whenever you want it, which might be very rarely, but it'll do it, right? I would market it that way. All right, HPC and big data. Hazards of forecasting big data. This is maybe my favorite topic in my whole deck here. We've done 2 major end user surveys on big data with hundreds of respondents spanning both HPC and non-HPC, and getting into the drivers, the barriers, the solutions, the applications, the technologies, everything that we can think of in there. We are not among the analysts that has come out with a forecast saying the big data market is umpty-ump billion dollars growing at 11% with a compound annual growth rate of something really fantastic. The reason is because when you say that the big data market is, I don't know, $10 billion or what, 30 billion I've seen, I don't know what one big data is and how much it costs, right? It really is a very poorly defined forecast to me, until you can tell me what specifically you're counting. And with big data in particular, most of the implementations we're seeing are started by writing in-house software and running them on servers that I already have, by people that I already have, using data that I already have. So in some sense, am I spending a substantial portion of my IT budget on it? Sure. I've got all these people, all this stuff that I've spent money on, and 30% of it is now going to big data. But I already had this stuff. So unless you're going back as an analyst and reallocating it from something else, I don't know what to do with that $30 billion number that you told me. I think there are 2 pertinent questions here in terms of providing guidance to the industry. One is, what percent of an organization's IT budget is associated with big data in some way? And we've got that one. Among people who are doing things that they call big data, the average is around 20–25% of the IT budget, which is a big number, right? That's not 20% of the HPC budget, not 20% of your storage budget. 20% of the IT budget is associated with big data, which is a lot. But then conversely, you got to say, well, how much more are you spending next year versus this year? What's the increment? And then compare that to the industry at large who's not doing big data. And when you look at it, the industry average among people who do have big data problems, they're looking at growing their IT budgets about 10%. So the delta between that and how much IT budgets are going up worldwide, regardless of big data, is the incremental money coming in, which is something, but it's not, you know, $50 billion. We do have new survey data out. 3 major insights for free without you having to buy the study. One is that it is a huge opportunity, like I was saying. 2 is that it's not just Hadoop. We found, when we first did our first study on this in 2012, and we asked end users to describe their big data applications, Hadoop was mentioned by 14% of respondents. And it was higher in academia than it was in commercial. Now, that's not to say that other people weren't using Hadoop, but it's not how they describe their problems. They might build something else on top of it. 2013, that number goes down. It was actually mentioned less often in 2013 than it was in 2012. So Hadoop is not in of itself a solution for big data. Now, what we do find is that more than half, of big data applications are in-house applications and algorithms. They are not, this is the Wild West out there. This is a hype versus reality problem. The vendor community has raced all the way down to, here are our complete big data solutions. The end user community is putting together stuff, they're MacGyvering things together with shoestrings and bubble gum, right? That's the reality of where the big data market is right now. Not that there won't be some killer app that starts to unite it, but you know, it's not like it's Hadoop and you know, that's everything, right? If you think about it this way, the message, we can help you scale your in-house applications and algorithms, has 4 times the resonance with the end user community of we can help you scale Hadoop. But no one says the former, and so many people say the latter. You know, we're really backwards on how these big data solutions are marketed right now. The reason it matters is insight number 3, which is up here, which is that performance really matters in this space, even to the enterprise player. When we look at the technical or HPC respondents versus the non-technical or the enterprise respondents, we find that they rank the top what we call satisfaction gaps. There's a whole methodology behind that, but just go with me for a second. The satisfaction gaps in the market go 1, 2, 3, and with number 1 being I/O performance or scalability for both groups, and it's the same. And this is weird because the enterprise side isn't supposed to put a technical performance metric as the number 1 thing. It's always supposed to be RAS. Right? Reliability stuff is always supposed to be number 1 over there. And it is until you get to big data. And then all of a sudden it's the same performance metric that the HPC people care about. So all of the HPC companies who are trying to market a high performance solution into enterprise because of big data are spot on. That is needed there. It really is. It's this great thing where all of a sudden, congratulations enterprise, you care about performance. You know, let's go talk about it. I did an entire hour-long thing on this slide at the Storage Developer Conference. That's the link. Okay, the other one I can't avoid talking about is the Lenovo deal, which is a slide that I just added in. This just happened. Looking at it from the Lenovo side, Lenovo immediately becomes a heavyweight HPC server provider overnight. Lenovo will vie for the number 1 revenue spot in HPC servers. It is currently IBM. It is currently IBM by a fair margin. IBM has about 31 point something % share. HP is second with about 21 point something, and Dell is right behind HP with 20 point something. So that means if Lenovo can hold on to more than 2/3 of that, Now, not all of IBM server revenue is x86 stuff, but most of it is. It kind of puts Lenovo into the catbird position of how much of that can they hold, and then whatever they lose, how much of it falls to the guys in the number 2 or 3 position. It's really very early to tell who will be the number 1 server vendor by revenue in 2015, but Lenovo is going to be in there competing it. Now, IBM doesn't go away. IBM continues to compete. They're taking a very application-centric viewpoint to HPC. They're focusing on the application, the workflow, the data, things like all the platform computing stuff, all the GPFS storage server stuff, not the server itself, but the GPFS components stay with IBM. IBM is all analytics, Watson, let's build a smarter planet. All that stuff stays there. They're still an HPC company. They're just not going to do the x86 bits. And from my personal analyst point of view, this deal actually plays pretty well into the strengths of both companies. Lenovo's great at doing stuff at volume. They really are. And they're going to crank out x86 servers at pretty low cost. And if you don't mind buying from Lenovo, then they're going to be right there with it. And IBM gets to focus on the high value parts that they really want to do. It does introduce a really interesting competitive picture of IBM versus Intel, because IBM manages to divest itself of everything that has to do with x86 in general, let alone Intel. And it eliminates the last major area where they were partners and leaves a lot of areas where they're competitors, including services and storage and middleware and processors and systems and maybe Exascale systems. You know, these are an interesting game of strange bedfellows going on. HP and Dell, you know, they've got to consider now what's their role going to be in HPC. I would tell either of those companies that they need to figure out what they mean from a complete system and solution point of view, or else what is there to distinguish HP or Dell from Supermicro, right? If it's just putting blades in a rack and they're competing against Lenovo and Supermicro doing that, then that's going to be a tough way to go. But if HP and Dell can improve what they're talking about from a system storage solution perspective, they can go. I think there's a huge opportunity for some of the other supercomputing vendors, Cray, SGI, Bull, you know, ought to be looking at the IBM Lenovo deal and saying, geez, we got a chance to compete while this is a little confusing over here. There's an opportunity for AMD and NVIDIA to go to HP and Dell and say, you know, where are you going to be with the whole Intel thing, and do you want our solutions or theirs? It even has echo effects down into the storage market, because you start looking at how is Intel going to compete with storage. And there have been other acquisitions in play there. So this is a really fundamental shift in not just who's selling systems, but where some of the political alliances are. And that's a fun game to start thinking your way through if you're an analyst in this space. All right, almost done. Other stuff. All right, I talked about Exascale. If we mean exaflop, I think it will arrive in 2020. And I think I made this slide for the HPC, the Society for HPC Professionals event in December, just before Japan announced that they had a 2020 plan. So Japan will be there in 2020. Will China get there before Japan does? I don't know. They might. It probably depends what you mean by exascale, but they'll be there. I don't think the US will be there first at this point. Accelerated architectures will be the future for the volume of HPC, but we don't know yet what architecture that will be. And if having it be a future that's ARM plus GPU is a lot different from having it be a future that's the future of Intel Xeon Phi, right? Those are two really different trees right now, and it's hard to say which way that's going to go, or something else. I think ARM will play a role. We're seeing a lot of end users who are telling us that they want to experiment with ARM, and they will experiment with ARM, or a few that are already doing it. There is room for differentiated high-performance supercomputing providers to do hard things that are not well aligned to LinPack, and I already talked to death about shifting OEM alliances. Okay, that got to the end of my deck. Generally, this brings up about 80,000 questions, so I'll stop here. Thank you very much.